Hi, my name is Sebastian Matteau, and in this video today we're going to create our own interactive Python interpreter. In other words, we're going to create a program that is kind of similar to, for example, IPython or the Jupyter interpreter. That is basically a Python prompt in which we can type Python commands and then they are executed. Now we're going to add a pretty cool trick to our interactive Python interpreter. Namely, we're going to write all the variables that live inside our interpreter to a file, and then we can monitor those variables by monitoring the content of that file. Right? So that's a very cool trick to just keep track of where we are. Say that, for example, we define a variable x and we give it the value 10. Then we could, by monitoring the contents of that file, we could see that there A is a variable x and B that it has the value 10. Right? So just like, for example, the Spider Python editor also allows you to inspect the values of variables. Now, what is cool about this interactive interpreter is that in the process of building it, which is actually quite easy, we're going to use some pretty cool and advanced but very useful Python techniques. So we'll use concepts from functional programming, which is a style of programming that relies heavily on short functions. And we'll use higher level functions, which are functions that operate on other functions. And we will use referential transparency, which is basically the principle of keeping your functions completely isolated from the rest of the program. We will learn about the difference between statements, which are pieces of Python code that do not evaluate to a value, and they can be executed with the exec function, and expressions, which are pieces of Python code that do evaluate to a value, and that you can execute with the eval function. And finally, we're going to use generator functions and generator expressions, which are very cool ways to implement loopy behavior in a kind of sophisticated way. Now, all of this is fairly complicated compared to the rest of my videos, but I hope that you will be able to follow along, and I hope that you will learn a lot from seeing all this very rich combination of techniques in action. Now, without further ado, let's go to our empty Python script. And let's define the main entry point of our script, def main. So main is the function that will be our main entry point, and we're going to execute it only if we execute the script directly, right? That's kind of a Python consensus. And the way you can do that is saying if dunder name equals dunder main, then we execute the main script. In other words, there is a variable __name __, usually pronounced dunder name, and that has the value dunder main if we execute this script directly, and in that case, we want to call our main entry point. You've probably seen this before. Now, how does our main entry point work? Well, what we're going to do is first focus on the collecting user input. So I'm going to say for I, user input in get user input. Pass. So what I'm doing here is I'm using a so-called top-down programming technique. I'm starting at the very top of my code with the most conceptual thing, namely the main loop, and then I will gradually fill in the details. So what I'm doing here is I'm assuming that there's a function get user input, and as Atom is actually warning me, this function is not defined yet. And this get user input returns an iterator, something that we can loop over, that consists of actual user input and a counter variable I that will be 0 for the first user input, 1 for the second, etc. So let's define get user input. Okay, def get user input. How are we actually going to collect user input? Well, user input, first of all, we need to define a loop again, because we want to collect user input infinitely, possibly, right? Until the user actually cancels it. So we could use an infinite while loop, but we can also use an infinite for loop as follows. We can say for I in itertools.count. Oh, what is itertools.count? Itertools.count, let's first import itertools. And itertools is a module, a Python module, part of the Python standard library that actually has a lot of useful iterator functions in it, and count is one of these functions, and it returns a counter variable that increments indefinitely, infinitely. So it's kind of like range, right? That also has a counter variable in it, but whereas range always stops after a fixed range, count just keeps counting and counting indefinitely. So here we have an infinite loop with a counter variable. And what are we going to do then? We're going to say yield I, input in up. So This is what we will show by way of a prompt to the participant in, for example, in 0, in 1, etc. with the counter variable. And then input collects user input and returns that as a string. Then we yield that user input to get as a tuple together with the counter variable. Now what is yield? Yield is kind of like a return statement. You probably know what a return statement is, right? But if I would do return, the function would end immediately when this is returned. Whereas with yield suspends the function, yields I and user input to our loop here, then resumes again, yields the new user input, etc., etc., etc. So yield is a way to return a value from your function without actually ending the function. And then you can resume yield again, yield again, yield again, etc. And in that way, we can loop through what get user input yields. Now, if a function with a yield statement in it is called a generator function, sometimes called a generator coroutine. So if you hear someone talk about generators or generator coroutines, you know it's simply a function that has a yield statement in it. They're very powerful, very, very nice. Okay, now we have something that we can execute. Let's try it. Python 3, MyPython. But it does not do much, right? It collects input. So I can say I is 10. I can say print I. But we do not do anything with the things that we type in, right? We're not evaluating or executing the code. How can we exit this? Well, we can do that in two ways. We can say Ctrl-C, then we get a keyboard interrupt exception. Or we can say Ctrl-D, which is the end of file, and we get an end of file error. Now here we already see that there is some room for improvement in how we collect user input. Because we want, what kind of behavior do we want? Well, we want the IPython behavior, which is such that Ctrl-C, so keyboard interrupts are ignored, and end of file errors cause the interpreter to stop, but without actually raising this exception, right? So it should just silently quit the interpreter. So how can we do that? Well, we need to catch exceptions that may occur during input. So we try this and we say accept keyboard interrupt. So if a Ctrl-C is pressed, then we do nothing, pass. Accept end of file error. Then we do something, namely we break the loop. So keyboard interrupt should be ignored. We do nothing. End of file errors should result in us breaking this loop. If we break this loop, the generator function get user input will end, and this main loop will also stop, right? So essentially get user input returns an iterator that is as long as how many user inputs we do without pressing Ctrl-D. Now let's see if we can execute this. Up. If I say Ctrl-C, nothing happens. If I press Ctrl-D, we stop without actually seeing the exception. So now we have the behavior that we want. Okay, that's nice. Get user input is pretty much finished now. But of course, we also need to do something with the user input. So what do we need in order to actually do something with the input? First of all, our interpreter needs a globals dictionary that maintains the state of the Python interpreter in it, right? So basically, whenever we define a variable x in our interpreter, that variable needs to be stored somewhere, and that somewhere is our globals dictionary. And we're going to call that user globals. And we start with an empty user globals. Then we assume that there's a function, execute user input. We haven't defined that yet, but we will. And it takes the I, the counter, it takes the user input, and it takes the user globals. So, and that is the function that should define our user input. Should execute our user input. So say, let's start defining it. Def execute user input, I, user input, and our user globals. Okay, how can we do this? Well, the simplest implementation would simply be to use the Python exec function and execute the user input and pass the user globals as the globals dictionary. So here we say, okay, execute user input and use the user globals dictionary as the state of the interpreter. This actually works. So right now, if I execute it and I say print 10, I will get 10. If I say I equals 10 and I say print I, it also prints out 10, right? So we have the behavior that we want to some extent, but see for example what happens if I type in 10 plus 10. What I would like to see now is the result of that expression, namely 20, being printed out to the terminal. but that doesn't happen. And in order to understand why that doesn't happen, we need to understand that there are two types of Python chunks of code. We have statements, which are things that do not evaluate to a value. So for example, we have a for statement. For I in range 10, print I. If I execute this, it will do something, right? This is functional Python code, and it will print out 0 through 9 to the terminal. But this whole thing in its entirety does not evaluate to a value, right? This is not equivalent to anything. It is just an instruction to the Python interpreter without having actually a value itself. And that's a statement. That's very different, for example, 10 plus 10. 10 plus 10 doesn't really do anything. It doesn't really print anything to the terminal. But this does have a value. It does evaluate to something, namely 20. And that's a Python expression. Most things in Python are actually expressions, because even things that you don't really think about as expressions, for example, function calls, do return something. They do evaluate to something, so they're also expressions. For example, say print 10 will print out 10. But if I say print, so I do a double print, so let's say, what you see is the first print prints out 10, of course, and then this returns actually itself none. And then the second print statement prints out the none that was the return value of the first print statement, right? So even a print statement is actually an expression, and it evaluates to none. What kind of behavior do we want? Well, the behavior that IPython has and that we also want is that anything that evaluates to a value that is not none should be printed out. And if something does evaluate to none, it should not be printed out, because nonce are not considered interesting. And if something is a statement, it also should not be printed. The return value is undefined, right? There is no return value, so we also shouldn't print anything out. So how can we implement that? Well, here's where things get interesting. Right now, we explicitly call exec. We don't always want to call exec, because exec is for statements, and eval is for expressions. So what do we want? How are we going to choose between those two? Well, what we're going to do is define another function, exec function, user input. Exec function is going to be a higher level function that takes the user input and returns either eval or exec, depending on whether user input is an expression or not. An exec function will be a higher level function because it operates on other functions, right? Its return value is itself a function. And that's why it is by definition a higher level function, right? A very powerful technique from functional programming. So, okay, def exec function, user input. Now, how do we decide whether user input is a statement? Can we simply say if user input is a statement, then return eval, else return exec? Now, of course, this doesn't work, right? This is conceptually what we want to do, but it doesn't work. So how can we check if user input is a statement? Well, what we can do is try to compile it as though it is a statement with the Python compile function, which creates bytecode of Python code. And if that succeeds, it will be an expression. This is not correct, is an expression. If we succeed in compiling user input to an expression, then we return eval, otherwise we return exec. That's the logic that we're going to use. So it goes like this. We say try, compile, user input. So user input is a string, and compile will try to turn this into Python bytecode from the standard input. And we're going to assume that it's an expression, so we're going to use the eval technique of compiling. If this does not succeed, we get a syntax error. If it does not succeed, that means that it is either a statement or an entirely invalid non-Python thing. In either case, we use exec to execute it. If it does succeed, then an exception does not occur and we return eval. Okay. So right now we use either exec or eval to execute user input depending on whether user input is an expression or a statement. Let's see if it still works. Re-execute. If I say 10, 10 would be an expression. For I in range 3, print 3, print I, That's a statement, and both work, so they're fine. Now, we still do not have the behavior that we want, because what we also want is that we use the return value of this exec function and print this out to the terminal. However, we only want to print it out if it's not null. So we say if redVal is not null, and it will be none, for example, for expressions that evaluate to none, and it will also be none because exec, the exec function for statements, also returns none. So if redVal is not none, then we say print out up. So then what we do, we print out the counter variable and the return value. So now we're getting somewhere. Let's execute our code again. So if I print 10 plus 10, it will evaluate 20. If I say none, none is not interesting, it results in nothing. If I say for I in range 3, print I up, it will also work, right? So this is pretty cool. Now, what actually happens if we make a mistake? Let's start it again and say that I type x. X is a variable that has not been defined yet, so we get an exception. That makes a lot of sense that we get an exception, but we don't want this exception to bring down our whole interpreter, right? Which it happens now. Rather, what we want is that we simply, in a very neat way, print out that we have a name error and the message that belongs to this name error, but do not cause our interpreter to crash. In other words, what we need to do is catch errors, catch exceptions that occur during the execution of our code. So what we're going to say is try and then execute that code, accept any kind of exception, right? Because we can get value error, we can get a name error, whatever. And then what we're going to do is print the name of the error, so in this case name error, followed by a colon, followed by the message, right? That's a nice way to represent exceptions. So how do we get the name of the exception? Well, E is the exception object. It has a dunder class property that refers to the class, for example, the name error class. And the class itself will have a dunder name property that will represent the name of that class as a string. So this is not particularly elegant, but it's a way to get a string representation of the name of an object's class. So that's the first thing. And then after the colon, we print out the exception itself. Now, of course, if we get an exception, then we don't want to do anything else. There is no return value. So we say else if redVal is not null. What does this else mean? Well, the else part of a try except statement is only executed if there is no exception occurred, right? So if this went okay, we execute this. If we got an exception, we execute this. All right, let's save it. Let's execute it. Now if I say x, we get a name error. But if I do something that is valid, namely I define the x, print it out, I get 10. So that makes a lot of sense, right? So now exec user input is essentially complete and functional, but there is still something kind of wrong with it because it violates the principle of referential transparency. And it violates it in the following way. We have a user globals argument, and this user globals argument will be updated, will be changed, modified by exec or eval, or at least it can be. And this means that basically our function has side effects, namely it can do something to the arguments that we pass to it. And that is a violation of referential transparency. It means that our function is not completely isolated from the outside world. That is not necessarily always a bad thing, but in our case we want it to be referentially transparent just for the sake of style. So how can we make sure that our function does not have side effects? Well, first of all, what we say is we simply say user globals equals user globals dot copy. So we create a copy of the user globals dictionary, and then that's what we're going to adjust, what we're going to update. But of course, we need to communicate the updated user globals back to our main loop, right? We need to communicate it back to our main value, and we do that with the return. We say return user globals. And then in our main loop, we say, okay, user globals equals exec user input. Let me make this a bit nicer. So this may seem a little bit redundant, and it is redundant in a way, but it is clean in the sense that now we have a referentially transparent exec user input function that we know will not do anything that we don't want with its arguments. And in order to nevertheless allow it to communicate user globals back, we use a return value. right? So that is good style, I think. It is redundant, but it is also kind of good style. You don't always need to do it, right? But it's something to keep in mind. Now, finally, so now we actually have a functioning interactive interpreter. But now what we want to do is actually print out the user globals to, or write the user globals to user globals.txt. So right here in the bottom right, I'm monitoring the contents of user globals.txt. And what we want to do is print out or display all the variables that live in user globals here. Because that's a very cool way to monitor the state of our Python interpreter, right? So we're going to say save user globals. And first, we save our empty user globals variable. And then after every time that we've done something, we save it again. So we write the new user globals to user globals.txt. Now let's define that function, def save user globals. The first argument is of course user globals. The second argument is going to be default keyword path user globals.txt, right? So by default, we want to write it to user globals.txt. Now, what are we going to do here? First, we need to open the file. So we say with open path for writing as file. And then we're going to loop through all our user globals. So we're going to say for the key, so the name of the variables, the value in user globals, which is a dictionary.items. Right, so .items is a function or a method of a dictionary that returns key value tuples. And then what we're going to do is fd.write, so we write to the file, the name equals the value, and then we want to write also the type, just because that's kind of cool. So we say, let's do it like this. Key is the name, value is the value, and val.dunder class, as we've seen before already, right? .dunder name is the name of the class of the value. Okay, this actually works. This should work. Let's check if it works. Let's run it and let's say, okay, x equals 10. Oh, we have a lot of stuff in user globals.txt, but this is actually not what we want. Why not? Well, user globals contains a lot of stuff that Python keeps track of itself for its own purposes, and these are these dunder things, or like dunder built-ins. We don't really want to show those because now there's so much stuff here that we will never be able to find our x. So we need to actually filter this. So let's say, okay, let's assume that there's a function selected a user globals and it returns only the user globals that we're interested in. Yes, so let's define that. Def selected user globals. And here we're going to use a generator expression, which is very cool. It works as follows. Return up. So what we need, we're going to do some loopy behavior. A generator expression is kind of like a list comprehension and it has a for component in it. So what we're going to say is for key in sorted user globals. So we're going to sort the keys of the user globals and then we're going to loop through them. Then what we're going to do is return the key, that key, but also the value, user globals.key, right? So we get the value from the user globals. But we don't want all the keys. We only want the keys if the keys don't start, key doesn't start with, starts with a dunder, and or the key doesn't end with a dunder, ends with dunder, right? So we want to skip those keys that start and end with the dunder because those are these things like built-ins that we're not actually interested in. And then only those are returned as tuples of keys and values. And this whole construction right here is called a generator expression. It's a very, very powerful Python technique that's similar to a list comprehension. Now let's see how this works now. Up, IPython, x equals 10. There we go. We have our x. X plus is 1. Now it becomes 11. Y equals 11. Up. Very cool, right? Oh, it's all on one line. Slight update. Let's do a end of line here. Control D. X equals 1. Y equals a. All right, perfect. X equals 1. So now we have an interactive Python interpreter that behaves in X more or less like an IPython interpreter. We can monitor the contents of the globals dictionary here by monitoring the contents of userglobals.txt. And we've seen a lot of very cool Python techniques in the process of creating this interactive interpreter. We've seen referential transparency, higher level functions. We've seen statements, expressions, generator functions, generator expressions, etc. It's been pretty complicated. I hope you've been able to follow, but it's been very exciting, I think, and I hope that you've learned a lot of useful new techniques for your Python toolbox. Thank you very much for your attention.